Hello guys, welcome to another example. The question goes, a coil consists of 2000 tons of copper wire having a cross-sectional area of 0.8 millimeter square. The mean length per ton is 80 centimeter and the resistivity of copper is 0.02 micro ohms meter. Find the resistance of the coil and power absorbed by the coil when connected across 110 volt DC supply. So the first thing you must do, you must write your formula, which is equals to rho L all over E, where R is your resistance, is rho resistivity, L is your length, A is your area. So now, how can we get our length of the coil? We know that the mean length per ton is 80 centimeter. The mean length per ton is 80 centimeter. So, but we have to convert this 80 centimeter to meter. So converting 80 centimeter to meter, we divide 80 divided by 100. We'll get 0.8 meter. So, but they told us that the number of tons is 2000. Number of tons is 2000. To get the length of the coil, we'll say this 0.8 times 2000, the number of tons, which will give us, that is 0.8 times 2000, which is equals to 1600 meter. That is the length of the coil. So now we've gotten our L. The next thing is for us to find our area. From our question, they told us that the cross-sectional area is in millimeter square. So that is 0.8 millimeter square. So now converting millimeters to meter, we divide by 1000. But in this case, since it's millimeter square, we divide by 1000 two times, which will give us 10 raised to the power of minus 6 meters. So now the next thing for us to find is to find our resistivity, which is rho. From our formula, they told us that copper resistivity is 0.02 micro ohms meter. So now all we just need to do is to now substitute all the parameters in which we derive into this formula. So now substituting into the formula, we have R, which is equals to rho L all over A, which is now equals to 0.02 times 10 raised to the power minus 6 times our length 600 all over our area, in which we converted to meters, times 10 raised to the power of minus 6. So multiplying everything with your calculator, you will get 40 ohms. So now I've gotten our resistance. That's for the A part of the question. So now the second part, we're asked to find the power absorbed. So now the next thing is to find the power absorbed. So now power absorbed, from our normal power formula, we know that power is equals to V square all over R is equals to I square R. and is equals to IV. But in this case, we'll be using the first formula since we have our V and we have our R. So we have our voltage and we have our resistance. So now power is now equals to 110, which was given from our question, which is the DC supply square all over our resistance, which is 40. So now using your calculator to calculate everything, we will arrive at 302.5 watts. So power is measured in watts. Size 302.5 watts. Thank you.